All right, jumping right into it today, we're talking large language models. You know, those AI systems that seem to be everywhere, the ones writing everything from lines of code to uh, poetry.
Right, they're becoming more and more commonplace. You see them in all sorts of things these days, like chatbots or even, search engines.
Exactly. And it's amazing what they can do, but there's always that question. What happens when an LLM runs into something new, something it's never seen before?
Yeah, that's a real challenge. It's like when you ask your GPS for directions to that new restaurant, the one that just opened. It might get you close, but without that latest data, you very well might just end up totally lost. That's where this idea of data augmentation comes in.
Okay, so no more getting lost. So we're basically giving these LLMs access to even more data, external data, kind of like giving our GPS a live traffic update.
Yeah, that's a good way to think about it. And the paper you sent, it really gets into how we can actually do this, how to make it effective, I mean. It's more than just throwing more data at the problem. We need to understand what kind of data, which data works best for different types of questions.
So it's about being strategic, working smarter, not just harder, which
Yeah.
of course everyone can appreciate. This paper, by the way, it's a preprint from Microsoft Research Asia. It's coming from a pretty credible source. Can you tell me more about how to categorize these different types of questions?
Sure. So they propose a system that they call the RAG task categorization method. Basically, it breaks down user queries into 4 levels. Each of these levels requires a different approach to data augmentation.
Okay, so 4 levels. Let's break that down a bit further. What are these 4 levels?
Well, they have names. They talk about explicit facts, implicit facts, interpretable rationales, and hidden rationales. I know it might sound a little technical at first, maybe even a bit jargony, but it's actually fairly intuitive. Once you understand the core concepts, it all makes sense.
Okay, you've got my attention. Walk me through these levels.
All right, so level 1, the explicit facts level, is the simplest one. Think about asking, what is the capital of France? The answer, it's a very clear-cut fact. It's something you can get directly from a database.
Makes sense. Like a super-powered Google search then, right? You get a direct answer to your direct question. What about level 2?
So level 2, implicit facts, that's where things get a little trickier. Here, the answer isn't going to be directly stated in the data. Instead, you kind of have to infer it. You have to combine multiple different pieces of information together.
Okay, so it's like a puzzle. You need all the pieces to see the bigger picture. Can you give me a real-world example?
Sure. Imagine asking an LLM to determine the environmental impact of a product. Now, you're not going to find a single document that just lays that all out. You need to look at data about how the product is manufactured, the materials used, how it's transported, all of that. The LLM has to take all these different data points and bring them together, connect the dots to draw a conclusion.
I see what you mean. That's a great example. So we're going beyond just finding information. We're talking about actually processing it, analyzing it. I'm guessing it gets even more complex as we go up the levels.
Yeah, it definitely gets even more complex. Level 3, this is interpretable rationales. Now it dives into the reasoning like the reasoning behind some decision or maybe like a guideline. I'm going to try to explain it this way. At level 2, we asked our LLM to figure out the environmental impact, right? But with level 3, we're asking it to tell us why. Why does a certain manufacturing process have a bigger impact than another one? And we wanted to base that on, real environmental science.
Ah, okay. So it's like the LM is learning to actually think critically. It's not just about crunching numbers. That's impressive.
Yeah, it is. And this is where it gets important, this whole idea of making sure that the external data we're feeding these LLMs, it needs to be high quality. It needs to be reliable because they are learning from it.
Oh, absolutely. Garbage in, garbage out. Okay, so now you really have me curious. What in the world is level 4? The hidden rationales. It sounds mysterious.
Okay, so think about situations where the reasoning isn't clearly spelled out. Situations where you really have to analyze those patterns, historical data, to figure out the underlying logic. It's like,
Bro, this is giving me like Minority Report vibes. Is that a bad thing? Predicting something, some future outcome based on all this complex data?
Not a bad comparison. Imagine an LLM that could look at all this data, a company's financial history, market trends, even sentiment on social media. And it could use that to actually predict how a new product launch would go.
Wow, that is next level. But how do we even start to get these LLMs ready for that kind of analysis? You mentioned ARG earlier. Is that a part of this?
You're right on. ARG, or Retrieval Augmented Generation, is a big part of how this works. Imagine this. Instead of just giving an LLM access to a massive library, one that's totally disorganized, Argy is like giving the LLM a really, really good librarian.
Okay, I like that. It's definitely helpful to have someone who knows their way around the library, who can pull the exact information you need. But in reality, how does art actually work?
So it's a three-step process. Data processing, data retrieval, and then response generation.
Yeah.
And each of these steps, they're all important. We need to make sure that the LLM is not only getting the right information, but that it knows what to do with it.
All right, so 3 steps. Let's break those down a bit. What exactly happens during that first step, during the data processing?
Think about how much information is out there, right? And it comes in so many formats. Texts, spreadsheets, we've got images, videos, you name it. Data processing is taking all of that and making it something that the LLM can digest, converting things into that common language that it understands, structuring the data, even breaking it down into smaller, more manageable chunks.
So kind of like prepping your ingredients before you can start cooking, right?
Right.
You got to chop those veggies, measure everything out. Otherwise, who knows what you'll end up with.
Exactly. And just like with cooking, the way you do that prep work, it matters. This paper, it talks about some really interesting techniques for this stage, for optimizing this stage. It's all about making sure the LLM is getting the best, the highest quality data possible. Okay, so we've prepped our ingredients. Now we need to actually find the ones that we need for this specific recipe. That's the data retrieval step.
Exactly. And this is where it gets pretty technical, but really cool. The paper talks about 2 main approaches to this: sparse retrieval and dense retrieval.
I might need a bit of help with those. I'm not sure I've heard of those before.
Okay, so think of sparse retrieval like using keywords, just like when you're searching for something online. It's like you type in a few specific words and hope for the best. Dense retrieval, on the other hand, that's different. It's more nuanced. It actually uses these things called BERT-based encoders. These help represent the meaning of the words and phrases in a multidimensional space.
BERT-based encoders. Okay, you've officially lost me.
Sorry. BERT. Let me back up.
Yeah.
It stands for Bidirectional Encoder Representations from Transformers. Basically, it allows the LLM to understand context. It can see how words relate to each other, not just their literal definition. It's like knowing the difference between when someone searches for just apple versus apple pie recipes.
Yeah.
They probably don't want to know about their iPhones.
I see what you mean. Context is everything. So dense retrieval is helping the LLM find information that's actually relevant, not just something that matches on a surface level.
You got it. And these BERT-based encoders, the cool thing is that they can be trained on these massive data sets. So they already come with this like deep understanding of language, of how concepts are connected. This makes it so much easier, so much more accurate for the LLM to find what it needs.
That's incredible. Okay, so we've prepped our data, found the right information. What's next? What's the final step in this whole RAG process?
Right, so that last step is response generation. This is where it all comes together. The LLM takes all that information we just talked about, all that retrieved data, and uses it to create a response, hopefully a good one, to the user's question.
This is where the magic happens. But it can't just be about, copying and pasting. How do we make sure the LLM is actually putting this information together in a way that makes sense, in a way that adds value?
That's the million-dollar question. The paper talks about a few ways to do this. One is supervised fine-tuning. Basically, it's like training the LLM with examples of really good responses. It learns how to use that retrieved information to draw conclusions and how to present everything in a way that flows.
So it's like we're giving it good communication skills. We're showing it what a good answer looks like.
Exactly. They also talk about joint training. This is where the retriever, the one finding the information, the generator, the one writing the response, they actually learn together. They kind of refine their act as they go, leading to, hopefully, more accurate and relevant answers over time.
Like a dance, right? They have to move together. But we talked about how not every question is a simple one. What happens when we go beyond those, those fact-based searches and into the world of hidden rationales?
That's when things get really interesting, I think. RAG is super powerful, don't get me wrong, but even the best tools have limitations. So when we're dealing with these really complex questions that need a deeper level of analysis, a deeper level of reasoning, that's when we need to bring in the more advanced techniques.
Okay, like what? Can you give me an example of one of these more advanced techniques?
One that I find fascinating is in-context learning. Remember how we were talking about hidden rationales earlier?
Yeah.
How they're often kind of embedded in examples and past experiences?
Yeah, it's like learning from watching someone else, not just reading about it in a textbook.
Exactly.
Yeah.
So in-context learning uses that. Imagine giving an LLM a bunch of case studies. The LLM looks at these examples and starts to notice the patterns, the rules, all that stuff that isn't always obvious.
So the LLM is developing its own intuition almost. Wow, that's pretty incredible. But I imagine it's super important to pick the right examples.
Oh, 100%. And that's one of the big things researchers are working on right now, how to find those perfect examples. The paper talks about some approaches like using semantic similarity, but they also say that sometimes you need a wider range of examples, to make sure the LLM can handle whatever's thrown at it.
Makes sense. You don't want your LLM to have a limited perspective.
Right.
You want it to be able to adapt to new situations.
Right. That's what's so exciting about all of this research. We're not just trying to make these LLMs bigger and faster. It's about making them smarter, giving them the right tools and training to really unlock their potential.
I think that's a perfect way to put it. So it sounds like data augmentation has the potential to change the game for LLMs, but it's not as simple as just, hitting the add data button. We need to be thoughtful, really consider the types of questions we're asking, and choose the right strategy for the job.
I totally agree. As we see these LLMs become even more common in our everyday lives, understanding these things, these nuances, it's going to be critical if we want to use them effectively.
Well, I know I've learned a ton today. It's so cool to think about how far LLMs have come and what the future holds, especially as we continue to refine these data augmentation techniques.
I think so too. It's a rapidly evolving field, and it's an exciting time to be following it all.
It really is. Well, this has been a fascinating dive into the world of data augmentation and LLMs. Thank you so much for joining us today. We'll be back next time with another deep dive into the latest research.